On Bitwise Assembly, let's talk about pipes in Satisfactory 1.0. The test stands here were built on Update 8, and tests were performed in both Update 8 and 1.0. There is only one discernible difference in 1.0, which is the impact of autosaves on fluid movement. In Update 8, the autosaves paused the game during the save, which seemed to cause issues with fluid momentum, which in turn would cause a temporary reduction in flow for some network types. 1.0 has mostly fixed that. With that out of the way, the remainder of this video will be going over some of the tests and applying the results to liquid recycling. Let's head over to a little test I call Everything is a Fluid Buffer. In Satisfactory, the fluid moving between machines is part of the floating point fluid network. This network operates with an allowed overfill of 140%, which is the basis of the pressure system, which I will talk about later. Every pipeline component has some hidden volume either as part of the 140% or a hidden fluid buffer. The pipe segment we're draining from has a displayed max volume of 10.6, but we got over 14 from it. The pipeline junction has a hidden normal volume of 10. Overfill pushes that to 14. The fluid inventory in machines is stored as an integer measured in liters but displayed in the UI as cubic meters. You will see the larger number if you add liquid to your to-do list. For machines with pipe connections, the fluid buffer only exists if the pipe is connected. Valves, pumps, and machine interfaces all have a normal volume of 5. Overfill pushes them to 7. There is only one pipeline component that does not have a hidden buffer, and that is the floor hole. The volume of the floor hole is added to the first pipe connected to it, which is why dismantling the floor hole also dismantles the connected pipes. Next, we're going to talk about pipeline junctions in two test regimes, fully saturated flow and empty flow. Fully saturated flow is useful for liquid recycling, and empty flow is useful for overflow systems. The test stands here allow me to measure the precise fluid priority. All the packagers and unpackagers are set to 60. Flow is from the left to right, which is west to east. The containers of packaged water are not connected to the surrounding belts during the test. The belts are there to make resetting the test easier. All tests were performed 10 times with each pipe version, 5 of which in Update 8, 5 of which in 1.0. The Mark I pipe tests were extremely consistent, while the Mark II pipe tests had a 1% deviation. I'm covering these tests in a better progression order rather than the order that I built them in, which is why you'll see the numbers jump around. I expected a higher prioritization of the Mark II pipe over the Mark I. Assumptions are always worth testing. When the pipeline junction is flat, the tests make sense. When the pipeline junction is not flat, it starts to prioritize the lower input, and it appears to ignore all other differences. When the junction is vertical, there is an extreme prioritization of the low input. This would be why the VIP junction works, and something we will exploit later in the video. Switching gears to the draining tests. Pipes start empty, and the packagers are still set to 60. Back at a flat pipeline junction, the tests make sense as the higher input gets nothing. The tests get weird again when you tilt the junction, but it sheds some light on how junctions are programmed. The junction does not check the node height of the attached pipe and relies on the programming of the pipes to dictate the flow. This is why the top pipe on test 6 receives so much flow. The pipe flows downhill to the packager, while the bottom pipe on test 6 flows downhill to the junction. So the angle of the pipe dictates the flow of an empty pipe. To demonstrate some liquid recycling methods, we're jumping to the co-op world I share with my son. We are starting at our quartz purification and distilled silica plant. Distilled silica uses 80% recycled water, which is one of the more difficult recycling loops in the game. But the bottom tap pipeline junction handles it without the need for valves, buffers, or unpowered pumps. You can set up this bottom pipe to clip less, but doing so makes it difficult to deploy even as a blueprint. This plant also does pink diamonds and time crystals. Let's go to a more common recycling loop, bauxite to aluminum scrap. Try to ignore all the dismantle boxes. He's 8, and like in his room, cleaning up is a low priority. Up here I have two versions of sloppy alumina to aluminum scrap factories using the new and old water recycling methods. Sloppy alumina, aluminum scrap, has a 60% recycled water rate, which is moderate difficulty. We're using the bottom tap junction again for the new factory, and it has had 0 issues. Let's take a look at my previous solution down below. I am using an elevated return for the wastewater with a valve and an unpowered pump to make the vertical pipe a buffer, all going to an isolated junction. This solution is stable, but complicated. I've only left the old solution standing for this video, so let's restart the new factory. These blueprints will be in the channel links. I hear you saying, but hey Bit, how do you jack up your buildings like that? And I'll show you. You take a 2-meter half foundation and place the building of your choice on it, and then dismantle the half foundation. Now let's look at a spicier application for the bottom tap junction. My son really enjoys playing Satisfactory with me. He is all about the unlocks and collecting all the collectibles. But he does help me build the factories. Here is our 75 gigawatt nuclear power plant like the ones from my past videos, but updated for 1.0. It only uses 4 alternate recipes. All of the spicy components use balancers. Some of the factory parts are underclocked to make balancing easier. There are 2 liquid recycling loops here, one for sulfuric acid and one for water. Encased uranium cell has a recycle rate of 25%, which is an easier loop. You can see here where we use the bottom tap to recycle the wastewater. Non-Fissile Uranium has a max recycle rate of 50%. I would like to thank those who have subscribed to me. Somehow I stumbled my way to 1,000 subscribers without ever talking. I enjoy making these videos, and I need some suggestions for where I might continue to go. I could update my previous videos for 1.0 because some of the power plants are no longer compatible to 1.0. I could build some of the newer fuel power plants, do the full recycling with Fixonium, or I could continue to do random test videos. Thanks again for watching.